Hello, America. I'm Kimil Chandler, and this is Qualitative Listening. We introduced a new concentration measure of banks holding of reserve balances, the asset-weighted Gini Coefficient, which controls for the differences among banks in size. In a departure from the traditional measure, the asset-weighted Gini Coefficient finds that reserve balances have been more evenly distributed since the 2008 crisis. The asset-weighted Gini coefficient suggests that ignoring the fact that U.S. banks are vastly different in size would artificially inflate the concentration. Reserve balances play a crucial role in the banking system. Prior to 2020, they satisfied reserve requirements, and they also serve as primary payment instrument for settling transaction and client orders via the FedWire system. Maintaining adequate reserve balances allows banks to meet withdrawal demands and instills depositor confidence, reducing the risk of bank runs. Empirical studies have demonstrated that banks' holding of reserve balances affects the provision of bank credits to firms and households. Although the relationship depends on types of credit and methods of reserves being injected into the banking system. Since the Federal Reserve gained the authority to pay interest on reserves in 2008, reserve balances have also become a popular investment for banks. The share of U.S. domestic banks' assets held in reserve balances have increased significantly, rising from less than 1% in the fourth quarter of 2001 to slightly below 6% in the third quarter of 2024. However, despite their importance, reserve balances are not equally distributed among banks. Concerns have been raised about the concentration of reserve balances among a few large banks, particularly following rounds of quantitative easing. 3 addressing the 2008 financial crisis, and 1 addressing the COVID-19 pandemic. These programs injected substantial reserve balances into the banking systems to finance the Fed's purchase of government securities, amplifying concentration concerns. In response to these issues, we introduced a new measure of reserve balance concentration based on our ongoing research. The asset-weighted Gini coefficient. Similar to the traditional Gini coefficient, this metric ranges from 0, indicating that reserve balances are equally spread among banks, to 1, indicating that reserve balances are concentrated entirely in a single bank. Unlike the traditional Gini coefficient, however, this measure accounts for differences in both reserve holdings and bank size, providing a more comprehensive perspective. Figure 1 shows how the two measures have trended over the past 2 decades. Our new metric has been decreasing over the past few years, meaning that reserve balances have become steadily more evenly distributed. By contrast, the Gini coefficient has actually been increasing during that same period. Our finding offers new insights into the evolving dynamics of reserve balances within the banking system. So what is the traditional Gini coefficient? The Gini coefficient is a traditional measure of inequality. It quantifies the share of the area below the 45-degree angle, the line of perfect equality that lies above the Lorentz curve, as illustrated in Figure 2. The Lorentz curve illustrates the distribution of variables such as income, wealth, or reserve balances across all members of a group. In our context, the Lorentz curve plots the cumulative percentage of reserves against the cumulative percentages of banks. The traditional Gini coefficient ranges from 0 to 1. Perfect equality. If reserves are distributed evenly among banks, the Lorentz curve aligns with the 45-degree line. In this case, the area between the Lorentz curve and the 45-degree line is 0, resulting in a Gini coefficient of 0, greater inequality. As the Lorentz curve moves further from the 45-degree line, the area between the two lines increases. This leads to a higher Gini coefficient, reflecting greater inequality, maximum inequality. In the most extreme case, where one bank holds all the reserve balances, the Lorentz curve remains flat and stays with the y-axis before jumping vertically once it reaches the x-axis. Here the Gini coefficient reaches its maximum value of 1. So, why weight the Gini coefficient by bank assets? To understand the need for asset-weighted Gini coefficients, consider this analogy. Suppose we want to measure income inequality of regions A and B. We can compare their GDPs, but identical GDPs do not imply equality. For instance, if A has to double the population of B, then A would need to double the GDP for equality to hold. Measuring GDP differences without accounting for population size would exaggerate inequality. 2. Similarly, banks differ in size, and this must be recognized when measuring inequality in reserve balances. Larger banks naturally hold more reserves due to higher reserve requirements, greater payment demands, or larger investment portfolios. Treating all banks equally, as the traditional Gini coefficient does, artificially inflates inequality, and this is especially true for the U.S. banking sector, considering the size differences among banks. For example, Figure 1 demonstrates that we control for the reserve requirements and measure reserve balances in excess of reserve requirements. The upward trend of traditional Gini coefficient reserves downward. Returning to the earlier analogy, GDP per capita is a more appropriate measure for measuring income inequality of regions, as it accounts for population differences. Also, as an appropriate Gini coefficient should count every individual rather than each country. It means we should use population-weighted measures on the Lorentz curve. This approach yields the same total GDP, but weighing each country by population allows the Gini coefficient to better capture inequality. Alright, that's the show, folks. Thanks for listening to Qualitative Listening.